So today's lesson, we're going to look at integrating along the y-axis. Okay, so we're going to use rectangles that have an x length and a dy height. So in this case here, notice that we can work out this area. So before we were working out these areas along underneath the curve, we could also work out areas that are bounded with the y-axis in the curve. And to do that, we're going to use this distance along here, okay, which would be the x position of that curve. And then we will use the width of dy, okay, that width here. To do that, we need to have an x expression in terms of y. So we need to solve the x in terms of the f of y. And then we can integrate that using dy. Okay, so now maybe we should just talk briefly about why we would use something like this. We might use something like this because this function here, when we solve for x, is sometimes easier to integrate. Sometimes it's to do with the orientation of the area as well. Okay, sometimes we want to find this area in here. Now, we could find a rectangle and subtract the area underneath as well. So it's more to do with a little bit to do with the geometry of how it's set up. Okay, so that green area there versus this red area in here. But probably more in a more useful way, it's to do with whether we can arrange it as an x equals expression that is easier to deal with than the y equals expression. Okay, so let's try some examples here. Here, this is just geometrically set up where we have the area between y and the curve. So it sets itself up a little bit easier to use a rectangle that looks like this, an x width and a dy height. Okay, so the first thing we would do is to rearrange this expression in terms of a x equals. So we would say x equals square root of y. It would be plus minus, but we're going to use the plus side because we're only going to use the positive x values here. Okay, so once I expressed it, rearranged it in its inverse in terms of x equals y, we can then find the area by integrating from y equals 0 to y equals 4 of square root y. Okay, that's going to give me the length of this line, x. Okay, that's going to be our x times dy. Okay, so that's what it looks like. And again, just a reminder that this is equivalent to the x position on the graph. That gives us our width. So this is an expression that's consistent. It's in terms of y. We're integrating with dy. We end up with an integral y to the 3 over 2. And then divide by 3 over 2, we get 2/3. And we're going to integrate from y equals 0 to y equals 4. So plugging that in, we end up with, looks like that's going to be square root cubed, and then minus 0. Okay, so 4 square root cubed is 8, minus 0, so we get an area of 16 over 3 units squared. Okay, so there's a general way we do it.